Coagulation, primary hemostasis overview. Hemostasis is the complex process by which the body spontaneously stops bleeding and maintains blood in the fluid state within the vascular compartment. Primary hemostasis consists of platelet adhesion, or the formation of an initial platelet plug, and platelet activation. The major systems of hemostasis are the blood vessels, platelets, coagulation proteins, fibrinolysis, and serine protease inhibitors. The minor systems of hemostasis are the kinin system and the complement system. The vascular system consists of the endothelial cells, the smooth muscle, and the connective tissue. The cellular components consist of the platelets, granulocytes, monocytes, and lymphocytes. The non-cellular components consist of the coagulation factors, the fibrinolytic system, the serine protease inhibitors, and the complement system and the kinin system. The vascular system, non-cellular components, and cellular components are all components in themselves of hemostasis. Primary hemostasis is the formation of a platelet plug. The platelet plug is fragile and easily dislodged. It initially halts the loss of blood. Platelets interact with damaged endothelium. Secondary hemostasis is the reinforcement of the platelet plug by fibrin formation. It involves the coagulation cascade proteins that interact with each other and the platelet plug. It allows the healing of the damaged tissue. Primary hemostasis includes vasoconstriction near the vessel injury to allow platelet aggregation, and then blood clot formation. The vascular system is made up of the adventitia, or the outermost layer, the media, or the middle layer, the intima, or the inner layer, and the endothelium, which is non-thrombogenic. Vascular action begins with contraction of the vessels, or vasoconstriction, and reflex stimulation of adjacent vessels. Then diversion of blood flow around the damaged vasculature occurs. Initiation of contract activation of platelets with subsequent adhesion, release reaction, and aggregation, and then contact activation of the coagulation system, both extrinsic and intrinsic, leading to fibrin formation. During platelet adhesion, von Willebrand factor adheres to subendothelial collagen. It then binds to GP1b5-9, and rapidly formed bonds are quickly broken and reestablished. Platelets roll along the injured vessel. The rolling slows them down. This allows the platelet signaling receptor GP6 to bind to collagen, which leads to a cascade of signals activating GP2B3A and platelet aggregation. Von Willebrand factor is synthesized inside the endothelial cells. When damage is done to the endothelial cells, von Willebrand factor is exposed and attaches to GP1b5-9 on the platelet surface, the initial tether of a platelet to the damage. Granules. Alpha granules include growth factor for healing, von Willebrand factor for platelet aggregation, fibrinogen for aggregation and coagulation, and factor V for coagulation. Dense granules include ADP for aggregation, serotonin for vasoconstriction, and calcium plus for coagulation. Glycoprotein 6 and GP1A2A bind directly with the collagen. More platelets come in and do the same. This is adhesion. Binding of all these receptors activates the platelet and causes the content of the granules within the platelet to be released. The phospholipid layer is made up of COX-1 and TX synthase. TXA2, thrombin, and A2 are released into the blood. Thrombin is made on the outer layer of the platelet and released as well. When platelets are activated, their shape changes. The surface area increases, and they form pseudopods or finger-like projections. During aggregation, ADP, TXA2, and thrombin recruit more platelets and bind to the receptors on their surface. ADP binds to P2Y12, TXA2 binds to TP, and thrombin binds to PAR1. This activates these platelets, which attach to already active platelets via fibrinogen and von Willebrand factor. These activated platelets then release more ADP, TXA2, and thrombin. The platelets are recruited until the plug is formed. Polyphosphate is a procoagulant and an antifibrinolytic. Coagulation testing. Coagulation tests measure your blood's ability to clot and how long it takes. They assess a person's ability to form a clot and bleeding versus clotting. The specimen mustn't be clotted when we start. Some coagulation tests are PT or prothrombin time, APTT or activated partial thromboplastin time, fibrinogen, TT or thrombin time, D-dimer, and FDP or fibrin degradation products. The three pathways that make up the classical blood coagulation pathway are the intrinsic, extrinsic, and common. The intrinsic and extrinsic pathways share the common pathway. APTT measures the intrinsic pathway and the common pathway. PT measures the extrinsic pathway and the common pathway. Thrombin time measures the common pathway. Platelets are 2 to 5 micrometers in size. They have a 7 to 10 day lifespan. Their reference range is 150 to 400,000 microliters. They are found 70% in the circulation and 30% in the spleen. In the formation of platelets, the myeloid stem cell is formed from thrombopoietin from the kidneys and liver. This becomes a megakaryoblast, which then becomes a megakaryocyte, which has extensions that are platelet precursors. Platelets are pieces, cytoplasm, and granules off of the megakaryocyte. They have no nucleus, and they do not reproduce. They are made up of a membrane, microtubules, an open canalicular system, mitochondrion, lysosomal granules, dense granules, alpha granules. The peripheral zone is made up of the glycocalyx, which is an amorphous exterior coat, the platelet membrane, which is a bilayered phospholipid with a negative charge for factor 10 and prothrombin activation, and glycoproteins on the surface. The open canalicular system, which are deeply penetrating surface connecting channels, and microfilaments. The platelet membrane glycoproteins are GP1A2A, which targets collagen and causes adhesion, GP2B3A, which targets fibrinogen or factor 1 and causes aggregation, GP6, which targets collagen and causes activation, and GP1B, which targets von Willebrand factor and causes adhesion. GP6 binds collagen, GP1B binds to von Willebrand factor, which binds to collagen. GP1A2A also binds to collagen, and GP2B3A binds to fibrinogen. During binding, collagen is exposed. Von Willebrand factor is released from endothelial cells binding collagen. GP1b binds von Willebrand factor, and GP6 binds to collagen. GP1a, 2a binds collagen. This is adhesion. Adhesion causes the release of ADP and ATP from granules, which stimulates the shape change and activation. The sol-gel zone of the platelet is made up of the platelet cytoskeleton, which is made up of microtubules and microfilaments. Microtubules are made of tubulin. Microfilaments are made of actin and myosin, which are contractile proteins and cause the platelet shape change. Tubulin keeps an inactive platelet discoid. An activated platelet squeezes in and promotes secretion. Actin and myosin also contract. Microtubules then become part of pseudopods. This activates GP2B3A and GP5. The organelle zone of the platelet structure is made up of mitochondria, cytoplasmic granules, and lysosomes. Cytoplasmic granules are made of dense granules and alpha granules, which release during secretion into the OCS. Secretion. OCS stands for Open Canalicular System. Secretions through it attract more platelets. Dense granules are ADP, which is non-metabolic and promotes platelet aggregation. ATP, which is non-metabolic and has uncertain causes. Calcium, which is a primary and secondary messenger that regulates platelet aggregation and activation. Serotonin, which promotes vasoconstriction, and lysosomes. The alpha granules are platelet-specific proteins which inhibit heparin, chemotaxic, which promotes smooth muscle growth for the vessel, beta thromboglobulin, which is meant for repair, platelet factor 4, which inhibits heparin, platelet-derived growth factor, which promotes smooth muscle growth and is involved in atherosclerosis and lipid metabolism, thrombospondin, which promotes platelet-to-platelet interaction and mediates cell-to-cell interaction, factor 5, which, once activated, complexes with activated factor 10 to convert prothrombin to thrombin, plasma proteins, fibrinogen, which is involved in fibrin formation, von Willebrand factor, which promotes platelet adhesion, factor 5, which is a cofactor in fibrin formation, factor 8, which is also a cofactor in fibrin formation, fibronectin, which is a cellular adhesion molecule and promotes platelet spreading, albumin, which has an uncertain effect, high molecular weight kininogen, which causes the activation of the intrinsic pathway via contact, alpha-2 antiplasmin, which inhibits plasmin, plasminogen, which is a precursor to plasmin and functions in fibrinolysis. Thromboxane A2. This is cyclooxygenase plus TX synthase. It recruits more platelets and binds to platelets to activate. Aspirin inhibits cyclooxygenase by inhibiting TXA2 formation and inhibiting platelet binding. Aggregation requires ATP from glycolysis, GP2B3A, and fibrinogen, and calcium, I think. Fibrinogen must bind activated GP2B3A complex. Once bound, calcium-dependent fibrinogen bridges between platelets. Serotonin is a vasoconstrictor and stimulator of smooth muscle production. Stabilization is achieved through the activation of the coagulation cascade. It occurs through secondary hemolysis. The lifespan of a platelet is 7 to 10 days. The platelet antigens that are receptors for collagen are GP6 and GP1A2A. The platelet surface antigen that is a receptor for fibrinogen is GP2B3A. Alpha granules are found in the cytoplasmic granules of the organelle zone. Platelets are pieces of the cytoplasm and granules from a megakaryocyte.